Okay, hello girls. If you don't know by now, or you probably do know, I am not in class today. So sorry I apologize to miss another class, but I have to attend the funeral of a close family friend. So I have to miss this block. But never fear, I should be back Thursday and I can catch up on any questions you guys have that you may not have answered with these videos. But today's agenda looks similar to last Friday. So first, you may have already done this, but if not, I want you guys to check homework. And in OneNote here, I have posted the answers over here labeled with today's date. I know you had 2 worksheets that were part of your homework on Friday. This first one was solving by taking square roots. So take a look at that one. One question you guys may have, a couple of these problems such as number 4 and a couple of the other ones, you could have, you would need to reduce to get to your final answer, and you can actually reduce before you take the square root or after. So for instance, if we look at number 4, when we get x squared by itself, we get 9/36. That can be reduced, 9/36 can be reduced to 1/4. And then you could take the square root of numerator and denominator, and you would get 1/2. Okay, or you could have, let me come up here, you could have, when you solve that x squared was equal to 9/36, you could have said, oh, well, those are both perfect squares, and you could take the square root then and get x equals plus or minus 3/6. And then at this point, you could see that 3/6 reduces to 1/2. So it really doesn't matter if you take the square root before you reduce or after, but always before you say it's your final answer, before you say you're finished with the problem, make sure you cannot reduce it any further. Okay, so I showed several of those kind of examples on here. And again, so if you have any questions, we'll talk about that next class. But hopefully you guys are able to correct your homework by looking at the answers to, this was the square roots homework, and this was the worksheet that was practicing solving by factoring. So I've worked them all out. So take a look. If there are some that you can't, that you need a little extra help on, you can ask a classmate for help, a neighbor, or I'm sure if you asked who's ever subbing, they could ask for volunteers to explain some problems if there's some questions. If not, rest assured, we will go over, I will review all this homework as needed on Thursday, okay? Okay, so after we've reviewed homework, we are going to go on and have some notes today, similar to last class. Today we're going to continue solving quadratics, but we're going to solve using the quadratic formula, which I know you guys have seen before in Algebra 1. It is super important, and we'll probably go a little bit more involved than you did in Algebra 1. But those will be our notes today. The video will be posted right down here after I'm finished with it. But it will also be posted on the LMS page that your sub is showing right now. Okay, so let's just kind of jump right in. So first, before we get into solving with quadratic formula, I want to kind of do a quick little review of all the different ways we have solved the quadratic so far. So, for instance, if you look at this first example, it's 3 terms, there's no GCF. So we would try to solve this by factoring, and we can think of what multiplies to positive 10 adds to negative 7. And you would say, well, negative 5 and negative 2 multiply to 10, add to negative 7. And then when we solve each of those, set each of those factors equal to 0, we get 5 and 2. Okay, now, if you remember from the first day we started solving, we're not graphing, but again, just to relate all this to the graph, what this really means is that we have a parabola that is crossing the x-axis at 2 and at 5, right? So if we wanted to sketch a graph, we could, and we would know that that's the meaning of these solutions, or these values, is where the graph is crossing. Okay, now I'll get back to that in a second. Let's look at this one. again, here we want to solve that. And we know that it has just an x squared term and a number term. So it falls under the requirements for solving by taking a square root. So we can get that x squared by itself. Pardon, my pen is kind of acting up here. I can add 20 to both sides. 4x squared equals 20. Divide by 4, I get x squared equals 5. I need x by itself. So I get x equals plus or minus radical 5. So again, radical 5 is kind of a weird number, but it's still the roots of this equation. So if I wanted to try to graph it, though, I'm pulling up my calculator here, I would want to turn radical 5 into a value that was more meaningful to me. So if I did square root of 5, I get 2.236. So we can also think about this as plus or minus 2.236. And there again, I could still kind of roughly or approximately graph my quadratic, and I would know that its x-intercepts were negative 2.24 and positive 2.24. Okay, so again, 2 ways we've learned to solve so far. But I want to look at a third possibility. Let's look at this example. Again, it's 3 terms. We've got an x squared, we've got an x, we've got a number. So let's follow our rules, our procedure, and let's set it equal to 0 and put it in standard form. So we get x squared minus x plus 7. Like, oh, well, this versus looks just like number 1. So we can think, well, we could factor that, and that would give us our roots. So let's think of what multiplies to 7 adds to negative 1. Wow, nothing really, right? Because the only thing that multiplies to 7 is 1 and 7, and there's no way that's going to add to negative 1. So it cannot be factored, okay? However, it is still a quadratic equation, right? We know it's still a parabola of some kind, okay? We know if we graphed it, it would somehow make a U-shaped. But we just cannot use factoring to find its x-intercepts, okay? And that's fine. We have other methods, and that's what we're going to concentrate on today, is the third method to use to solve quadratic equations is quadratic formula. The special thing about quadratic formula, it can be used to solve any quadratic equation. Whereas the methods we've learned so far have had their limitations, right? So I'm just writing this. So when we want to solve something by factoring, first of all, it has to be able to be factored, right? We have to be able to either use AC method or difference of squares or reverse FOIL or take out a GCF, but we have to be able to factor it. And you cannot always factor an equation. So that's not of use on everyone. Square roots, we know that to solve by square roots, it has to only have a squared term and a number term. It can't even have that middle bx term. So that's definitely limiting. The importance of quadratic formula is that it can be used to solve any quadratic equation. Okay? So you may think, well, why do we have to learn all the other methods? Not a bad question. But factoring and square roots are much easier and involve much less computation than quadratic formula. So if you want, so it's always faster, usually, and easier to use the other methods than quadratic formula. But we've always got quadratic formula kind of in our pocket, you might say. And then we will eventually learn how to solve some of them on a calculator. Okay, so again, this is just reiterating that all equations can be used with the quadratic formula. The other methods are only applicable in certain circumstances. Okay, so let's see what this is all about. And I know you guys have learned this before, and there's a little song that goes with it that I'll wait and sing with you all when I'm in class. I'm not going to record me singing a song, but there's one way you guys, I'm sure, know that you can sing it to remember the quadratic formula. But here it is. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's our formula. You will need to memorize it. Okay, hopefully we'll use it enough that memorizing won't present a problem, but you will want to memorize it. And here's the steps of how to use it. First, we write our equation in standard form. Again, we've been through this, ax squared plus bx plus c. Then we plug in just the values of a, b, and c. So these are only numbers that we're plugging into this formula. There's no variables when we're plugging in the formula, because the formula itself we set equal to x, okay? So we pull out our a, b, and c, plug it into this formula, and then we solve it. So simplifying the square root, simplifying it in various ways, okay? And this is the challenge here, is to simplify it correctly, and that's what we're going to practice. Okay, so let's go ahead and start with this first one. So if we look at this example, if we identify a, b, and c, you know a equals 1, b negative 7, always be sure and include your sign, and c is 12. Oops, my pen's really dying. C is 12. So now we've identified a, b, and c. We're going to plug those values into our formula. So let's come over here. We get x equals negative b. So again, just like when we did our vertex form, or our vertex, we're going to say negative no matter what. And then our b, which also happens to be negative, but that's okay. Now we're going to have a double negative. We'll clean that up later. Then plus or minus, you have to write the plus or minus because that's important too. Square root of b squared, so that's negative 7 squared, minus 4a, which is 1, b, excuse me, 4ac, which is 12, all over 2 times a. So again, all I've done right here is I've taken my a value. It only belongs in one spot. I've taken my c value. It only belongs in one spot. The really important value here is b, right? We have a negative b and a b squared. And then actually that 2a also comes into play, okay? So I'll plug it in. Now I want to simplify. So let's simplify first. We can say negative 7 is positive 7. Plus or minus, keep our radical here, negative 7 squared is 49. This number right here should always be positive once you're simplifying it, because any number, whether they're positive or negative, when you square, it's going to be positive. So we have 49 minus. A couple ways you can think about this. The way I like to do it is I like to go ahead and write my minus, and then I'm going to just look at these three values, and I'm going to multiply 4 times 1 times 12 is 48. So I get 49 minus positive 48, all over 2 times 1. I keep going here. I keep my 7 plus or minus. 49 minus 48 is 1 over 2. Okay, so first of all, I've simplified underneath the radical. I've done the math. Now I come out and I look at radical 1. So radical 1, square root of 1 is 1, right? Square root of 1 is 1. So now I can get rid of this radical altogether and just say 7 plus or minus 1 over 2. Now, this plus or minus actually gives me my two answers. If you notice when I solve for all these other values up in our warm-up, I always really expect two values because most quadratics will cross the axis twice. So this plus or minus in our quadratic formula is how we get the two values. I like to call it high road and low road. So the first is the high road, where I'm just going to use the plus sign. So I'm going to say 7 plus 1 is 8 divided by 2, and I get the 4. So that's my first x-intercept. Then I'm going to use the low road. So I'm going to say 7 minus 1 over 2 gives me 6 over 2 gives me 3. So my answer here is x equals 3 and 4. Okay. All right, so let's just keep trying some other ones. So, and you'll see the pattern. We always try to get it down to this with just one number underneath the radical. Then we simplify the radical. Then we apply the plus and minus. We really can only apply the plus and minus if we get the radical to go away. But we'll look at that in a second and see what happens. All right, so let's just try 3 more examples. So we look at this one. Again, I always recommend keeping that x squared term positive. So even though there's more terms over here, over on the right than the left, I'm still going to subtract and bring everything over to the left. So I get x squared minus x minus 2 equals 0. I'm going to identify my A, my B, and my C. So C equals 1, B equals -3, A equals 1, C equals -2. Now I'm going to plug it in. X equals negative B. B is -3, so I'm going to say -3 plus or minus B squared minus 4AC all over 2A. So again, I've set it up. You want me to check your work, make sure you agree with that. Now I simplify. So first I'm going to say -3 gives me a +3. Down my plus or minus. -3 squared is going to give me +9. Again, when you simplify that part, it should always be positive. And then I'm going to bring down my minus sign. And then I'm going to multiply 4 times 1 times -2. And that gives me a -8. So now I'm actually saying 9 minus a -8, which is going to give me 9 plus 8, which gives me 17. Okay. Actually, this is still all over 2. So let me show you that again. So when it comes to simplifying this second half of your radical, I always like to put down my minus sign first and then multiply everything else together. When it becomes a negative, if you get a negative number there, then minus a negative number is going to result in you adding. Okay. So I get to this 3 plus or minus radical 17 over 2. Okay. Now, I look at my radical sign and I think, can I reduce that anymore? So if I come over here, can I reduce radical 17 to anything? Is there any perfect squares in 17? And there's not, so I'm actually finished. I'm going to keep it just like this, okay? It still gives me my 2 values, because I could think about this as 3 plus radical 17 over 2, and 3 minus radical 17 over 2. But for our purposes, I would just as soon you guys keep it in this form. Okay? All right, hope that's going well. Let's try another one. I'm kind of writing kind of big here on my video. Let's look at this next one. Again, first thing we're going to do here is get it in standard form. So I'm going to add 3. So I'm going to say x squared minus 6x plus 3 equals 0. I've got my A is 1. A equals 1. B equals -6. C equals 3. Now I'm going to plug it in. So I've got x equals negative b, which is going to be negative b, so negative 6, right? Negative b, plus or minus the square root of b squared, so that's going to be negative 6 squared, minus 4, a, which is 1, c, which is 3, all over 2a. Plug in all my values. Now I simplify. Negative 6 becomes a positive 6, plus or minus negative 6 squared, again, is going to be positive 36, minus, now I get a 4 times 3 is 12, so 36 minus 12, all over 2. I keep going, I get 6 plus or minus 36 minus 12 is 24 over 2. Okay, now I'm looking pretty good here, but I always want to look at my radical, bring it over to the side, and think, can I do anything to radical 24? Yes, I can. I can think about radical 24 as 4 times 6, which is 2 radical 6. So now I'm going to replace radical 24 with 2 radical 6. My final answer is 6 plus or minus, oops, sorry, my pen is glitching. 6 plus or minus 2 radical 6 over 2. So I can't do like the high road, low road like we've done the first one because I did not get rid of that radical. So we'll talk about this more next class, but for right now, I want you guys, if the radical doesn't go away, just leave it in this form. We'll talk about what we could possibly do with like that 6 and these 2's later on, but for right now, just leave it the way it is. Okay? All right, let's look at one more example. So here, my equation's already in standard form, set equal to 0. So I'm just going to identify my A is 3, my B is 2, my C is negative 1. I'm going to plug those in. So I get, go ahead and a little structure here. So I get negative B. So my B now is just a 2. So it's going to be negative 2 plus or minus B squared minus 4AC all over 2A. So this one, the first one's where the A is greater than 1, but that's okay. Come down here, I simplify negative 2 gives me just a negative 2 plus or minus square root. 2 squared is 4. I'm going to bring down my minus. I'm going to look at 4 times 3 times negative 1 is negative 12. So now my 4 minus becomes a 4 plus 12. Again, because it's going to be 4 minus negative 12. It becomes 4 plus 12 all over 6. My 2 times 3 is 6. So now I keep going here. I get negative 2 plus or minus 14 plus 12 is 16. So I get plus or minus radical 16 all over 6. So again, I get down to this point and I say, okay, what can I do with that radical? I come over here. Radical 16 is a perfect square, right? It's 4. So now I can replace radical 16 here with its value of 4. So this becomes negative 2 plus or minus 4 over 6. Now I can do like I did in my first example, where I can go high road. So I'm going to say negative 2 plus 4 over 6. Gives me 2 over 6, 1/3. And I can also go when I say the low road, so that brings in the subtraction. So I get negative 2 minus 4 over 6. Gives me negative 6 over 6, gives me negative 1. So let me show you, let me highlight this a little bit. So the blue, I did -4, -2 plus 4 over 6. And then on the red, I did the minus, -2 minus 4 over 6 and -1. So my final answer is x equals 1/3 and -1. Okay, so there again, plug in your values, clean it up to where you get something like this. See what you can do with that radical. See if you can replace it or if you can purely just simplify it and see how far you can go. Okay, now this has been a lot, I know. So again, I apologize for not being there, but we'll go over this more. We'll take a long, long time next class. We have a whole nother day of quadratic formula, so I will be able to take all your questions next class. But what I want you guys to do now is work on the worksheet. I just want to show you, this is just an example. Your worksheet, the first couple problems on each side of your worksheet kind of guide you through it. Like it gives you the places to mark what A, B, and C is, and it even sets up your formula for you, like -b over, and then you have to just fill in the values. So I want you to do that, but then continue on with these. Even if it just starts with this and stops here, continue on and find the final answer for all of them, okay? But just because the first couple set this up for you, you still want to continue going, okay? So if you look at this worksheet, yeah, you'll see some of them, it kind of fills you in, but then it gives you space to keep going, okay? Just kind of gradually gives you more. So I'd like you guys to go and try all of these, okay? So go ahead and try both sides of the worksheet. See how you do, and we, like I said, you all can talk to each other if you need to, work together, help each other out, and we will go over these on Thursday. So anyway, thanks guys again for being patient, I hope, and attentive, watching these videos, and I will see you on Thursday. Bye.